Genetics problem number 7 says, in snapdragons, red flowers show incomplete inheritance with white flowers. Fill in a Punnett square and give the genotypic and phenotypic ratios of a cross between a red snapdragon and a pink snapdragon. With incomplete dominance, you can do the genetics the same. Different books have different ways of doing incomplete dominance Punnett squares. I tend to stick with the regular dominant recessive notation, but then know that my heterozygote is going to have a different phenotype. So in this case, I would use the big R for red and the little r for white, knowing that if I have two big R's, it's going to be red, two little r's going to be white. If I have a combination of heterozygote in between, it will be pink. So I have one red snapdragon, and red has to be homozygous dominant because this is incomplete. We're going to see if it's not homozygous dominant. And then the other one is a pink snapdragon, and pink is not either dominant or recessive, it's intermediary, so it must be a heterozygote. So we're going to cross those two together. Let me check my thing here. Cross between a red snapdragon and a pink snapdragon. So we're going to cross these. So one parent is red, one parent is pink. And like I said, not all books use the straight uppercase, lowercase notation for incomplete. I think it's easier than some of the crazy stuff they do. I don't remember offhand what your book uses, but it's easier to understand, I think, this way. Alright, so we have 2 out of 4 homozygous dominant. Here, it's an incomplete dominance, but since they are homozygous for the dominant trait, that would be red. We have 2 heterozygotes, but since this is showing incomplete dominance, even though they're heterozygotes, they wouldn't be red, they would be pink. So we have 2 red and 2 pink, even though they all 4 show the dominant trait. Because we're dealing with incomplete dominance, we would have pink here and not red.